Hey guys, thanks for tuning in. This is Dr. Barnes. In today's video, we're going to be looking at generics in Java. Specifically, we're going to look at creating a class that can contain objects of any type using generics. So before we get to the details of that, I want to show you two classes that we'll be using throughout this video. Over on the left, we have a camera class, which contains a single instance variable representing the resolution of the camera in megapixels. Then we have a simple getter and setter method for resolution, along with a constructor for camera objects. Over on the right, we have a class representing a drone, which has, again, a single instance variable representing the maximum height that the drone can fly, along with a getter and setter for that instance variable, and a simple constructor. Now we could have added additional instance variables to this class, to both of these classes. We could have added extra methods to make the drone class and the camera class a little bit more complex. But in this video, our goal is not to build a camera or a drone class. It's to look at how we can make a class that can contain objects of any type. The name of our class is going to be shipping container. And you can think of this class as sort of maybe a container that Amazon would use to ship objects to people. We don't want to create a shipping container for cameras and then a separate shipping container class for drones. The idea is to create one shipping container class that can store objects of any type. So the first thing we'll do is we'll put this into our CS1302.generics package. We will declare the class in the usual way for now. And you're used to declaring classes like this, but when we declare a generic class that can store objects of any type, we're also going to parameterize the class. Now you're used to parameterizing methods where you define formal parameters and then pass in actual parameters to the methods. Here, we're going to do something similar on the class, but instead of parameterizing a value to pass in, we're going to parameterize the type. So again, this is just a parameter. We could call this whatever we want to. We will call it content type as a placeholder for the type of the contents of the shipping container. And as we'll see in a little bit, when we instantiate objects of type shipping container, we will specify the type of each one when we declare it. So again, think of content type as the placeholder for the type of this shipping container class. So there's a couple of instance variables I want to declare here. The first one is the contents of the shipping container. And remember, at this point in time, we don't know the exact data type of this variable. But we do know that when objects are created, the type will be specified, and that will be passed in as a parameter or as a type argument. And in this context, we'll refer to that as content type. So even though we don't know what that is at this moment, we can use that as the type of our instance variable contents. We'll also go ahead and provide a weight instance variable representing the weight of this particular shipping container. Now we'll want to write a couple of methods. We should have a constructor, call this shipping container. We'll pass in the contents, which remember, we're referring to the type of this as content type, and we'll also pass in the weight. Now before I write the details or the body of the method, the constructor, we'll go ahead and write a setter for both contents and weight. So let's start off with setWeight method. It takes a weight as a parameter. We will make sure that the weight being passed in is actually positive. So if it's greater than 0.0, we'll say this dot weight equals weight. Otherwise, we'll just give it a default. We'll maybe set it to 1 pound if the user passes in something invalid. And then up in the constructor, we'll use our setter to set the weight, and that way it's automatically doing the error checking for us. So let's also make a setter for set contents. Now again, the type of the argument being passed in is unknown at this time, but we use our placeholder content type to refer to the value being passed in. And we won't do any error checking in here just to save some time, but we'll go ahead and say this.contents equals the contents being passed in, and again, in our constructor, we will call the setter. So let's take a second and look at what we wrote. Again, we have this placeholder called content type. Generally in Java, what you see is the convention is to use a single capital letter T for type, and that's to sort of help differentiate between a generic type parameter and a regular class. We're using content type here. Hopefully that will help you see what we're doing a little bit better. Also, for now, this class is incomplete. We need to add some java.comments, and we also want to add getters for contents and weight. So if you're following along, I encourage you to pause the video and add your java.comments as well as your getters for both contents and weight. And I'm going to do the same thing. And when I come back, you can check what you've written against the code that I've done. So go ahead and pause your video and we'll come right back. Okay, so we're back with our updated shipping container class. I'll point out a couple of things. First of all, I've gone ahead and added proper java.comments to all of my methods. Also added a java.comment to the class. And note that we use the @param tag on our shipping container class. And that's because the content type, remember that's a parameter, right? Comes in as a type parameter representing the type of the contents in this particular shipping container. Also, we already implemented set weight and set contents previously. Also added a get weight method to return the weight of the shipping container, and additionally added a get contents method to return the contents of the container. And note the return type. It's an unknown type at this particular moment, but when we run this, we will assign a particular type by providing a type argument to the constructor of shipping container. So let's go ahead and see how we do that. I'm going to save this. I'm going to close it. Let's first make sure that all of this compiles. So I'll compile to bin, and there are no dependencies here between from drone. There are no dependencies on camera, and there are no dependencies on shipping container. So all of those should compile without having to specify the class path, and they do. I'm also going to go ahead and run my check style. I've created an alias called style1302, which is an alias for the check style command that you guys are familiar with. So style1302 is run. It looks like everything checks out. I'm also going to go ahead, just to be sure, make sure we didn't have any errors in our Java doc. I'm going to go ahead and generate the Java doc. So source path, and looks like everything is good there. So now let's go ahead and move into a driver program, and we're going to create objects of type shipping container and place different types of objects within those shipping containers. Now I said that when we create objects of type shipping container, we want to specify a type parameter which gives the constructor the actual type of the object that's being passed in. So here we're going to declare a shipping container, and for the content type, So let me open up shipping container over on the other window so we can have a reference. So in the shipping container constructor, remember, we have the contents being passed in, and those are of some unknown type over in the shipping container class. So on the left in our driver, we want to specify what content type should be replaced with. Now, in this example, I'm going to go ahead and use drone. So we're saying that this particular shipping container that we're creating is meant to store drones. We'll call it drone shipping container equals new shipping container drone. And we'll pass in my drone along with some initial weight, which we'll just set to 10.0. For the next example, we can do the same thing with camera objects. Call this camera shipping container, new shipping container, type camera with my camera, and we'll say it weighs maybe 2.0 pounds, whereas the drone weighed 10 pounds. So that's how we would declare objects. Now, one of the important benefits of doing generics is that they allow us to do type checking at compile time. So for example, if I were to say drone D equals camera shipping container dot get contents, well, we all know that the contents of the camera shipping container is a camera reference, right? It's a reference to an object of type camera. So assigning it to a drone would not be valid because drone is not a parent of type camera and it's not the same type as type camera. So we're to try to compile this. Now when we compile it, we'll have to specify the class path because we have some dependencies with the other classes, the drone and the camera class. So we'll compile with bin on the class path, compile our driver, and forgot to put Java C. And now you see, this is exactly what we expected. It's saying that it cannot assign the contents of the camera shipping container to a drone reference, and that's because it's a camera, which can't be assigned to a drone. And this is one of the big benefits of using generics in Java, is that you get compile time type checking. And that's exactly what this is doing. It's saying the types don't match, and they're not compatible, and therefore this code cannot be compiled. Now let's look again at the driver. And we could have declared our shipping container to be a raw type. Now we don't want to do this in general, but I want to show you what happens if we were to declare a raw type. So in this example, I'm not going to provide a type argument to our constructor. I'm just going to call this raw shipping container. Make it a new shipping container. We'll pass in my drone, and maybe we make it 5 pounds. And because I didn't specify the type of this shipping container, Java is automatically going to assume that the type is object. Now remember, object is a parent of all of our classes. So any object can be referenced using an object reference. Now if I were to try to get the contents from our raw shipping container, as you might expect, since we didn't specify a type, this method is set up to return object. So if I said drone, we'll just call it contents, equals the contents of the raw shipping container, we are trying to assign the return value from get contents, which we just said is object, and putting that into a reference of type drone. So let's go ahead and save and compile. And I forgot to delete the first line, so let me go ahead and remove that. We showed that this was not valid, so let's remove that. Let's compile again. And notice it says object cannot be converted to drone, right? So we have, in this situation, we have the object coming back, which cannot be stored as drone. Now we can make this work. We can force this to work by simply casting that to be a drone. We're forcing the compiler to make this this return value be a reference of type drone. But the problem with that is that it's risky, right? We could say camera, call this camera contents, and we could cast the contents of our raw shipping container to be a camera. Now this is wrong, right? This is not something that we want to do, and in fact, the compiler is going to allow us to do this, even though we know that this is a mistake, right? This thing is returning a reference of type object, which can be cast down to a camera, but in this scenario, it's actually going to cause a runtime error, right? Because we're turning a drone into a camera, which is an invalid operation. So if I were to compile this, well, it's going to give me my warning message, right, saying that I have some unsafe operations. And that's because we are getting an object and casting it down. And when we run it, we see that we get a class cast exception. So I'd like to emphasize one final point here, and oops, open the wrong file. And that is that generics allow us to move some of these error messages to compile time. So if I were to open up the driver, we saw that when we incorrectly assigned the contents of a camera shipping container to a drone and we used our parameterized types, this did the check at compile time and forced us to fix it before the code would compile. On the other hand, when we used the raw types and we cast this object down to one of the types that we decided on, we see that we might make a mistake. We might end up casting a drone to a camera, which is going to cause the code to crash at runtime, right? So one of the big benefits of generics is that we can move this checking to compile time and not get runtime errors, which is always better for our users and always better for us to catch our bugs early on. Also, we were able to write a shipping container class that could contain objects of any type, right? So generics are a really powerful tool in Java, and we'll be seeing more about generics in the upcoming lessons. So see you next time.